lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikere, Dharmaburi. In this video lecture from upcoming semester Thermal 2, Unit 4, Cogeneration Waste Heat Recovery System. Previously from the Module 5, Module 6, we have to discuss about the waste heat recovery system. From this slide also we have discussed about the waste heat recovery system, how to increase the efficiency of the accessories. First of all, we have discussed about the economizer. Economizer is generally previously we have discussed about the from the steam turbine and the steam boiler. The main function of the economizer is to increase the efficiency of the thermal power plant. From here we have to using the economizers or heat exchanging device that heat fluids usually water up to but not normally beyond the boiling point of that fluid. Economizers are so named because they can make use the enthalpy in the fluid stream that are hot but not hot enough to be used in a boiler, thereby recovering more useful enthalpy and improving the boiler efficiency. They are device fitted the boiler which saves the energy by using the exhaust gases from the boiler to preheat the cold water used to fill it the feed water. The economizer serves a similar purpose of feed water heater, but it is technically different as it does not use for cycle steam of the heating. In that fossil fuel plants, the economizers are used the lowest temperature flue gases from the furnace to heat the water before it enters the boiler proper. This allows for the heat transfer between the furnace and the feed water across the smaller average temperature gradient. From here, the economizer is used for generally in the boiler thermal power plant. From here, the hot flue gases is merged on this tube from the economizer. From the tube, there will be water will be circulated. This water is goes to the feed water conditions. If we have touched from the heat exchanger, from the hot flue gases touch the tube, the boiler will be heating. That feed water they will improve the efficiency of the boiler, and also we have to economizer to improve the efficiency of the boiler performance. From here we have to using for scrubber. The scrubber is mainly used for that to cleaning the pipeline, because of if you have hot flue gases is merged on this pipe, there will be some carbon will be deposited and ash also is deposited in the pipe. Because of if the ash or carbon is deposited on the pipe means the heat transfer will be heat transfer coefficient will be decreased. So that condition we have to using for the scrubber. From the scrubber is used for that gear mechanism. From the reduction gear mechanism we have to continuously to clean the ash and dust particles in the pipeline. If you clean this ash and dust particles, mean we get the better efficiency from that pipeline, and also the water will be easily heated, and that water is goes to the feed water conditions. So that condition only we have to using for the economizer is generally used for that to increase the efficiency of the thermal power plant. It is one of the accessories for the thermal power plant. But in the nuclear power plant, they have no economizer. But the combustion engineering system, that 18 plus nuclear plant design, the evolutionary success from the Korea Electric Power Corporation in the app, it of the integral feed water economizer is present on the nuclear power plant. The economizer to preheat the steam generator feed water at the steam generator inlet using the lower temperature primary constant. Next slide we have discussed about the shell and tube heat exchanger. Generally we have tell about the shell and tube heat exchanger is one of the process of condenser process. What is the main thing from the main function of this shell and tube heat water is to waste heat is the liquid or vapor which heats the another liquid. Then the shell and the tube heat exchanger must be used since both the path must be sealed to contain the pressure of the respective fluids. The shell contains the tube bundle, and also usually internal fables are present to direct the fluid in the shell over the tubes in the multiple passes. From the shell and tube heat exchanger there is a tubes are present. From the tube there will be water will be circulated. From the tube they have fitted from the fables. What is the purpose of the fables means the water will be uniformly circulated from the all the tubes and merged. There will be heat exchanger. From the tube inlet the hot steam is entered to the tube. After from the outlet condition it will be cold. From that water there will be heat exchanging process will be happen on the tube. The shell and tube application is for the shell and tube heat exchangers include the heating liquids with the heat contained by the condensate from refrigeration and air conditioning system, condensate from the process of steam boiler, coolants from the furnace door, grates and pipe supports, coolants from the engine, air compressor, bearings and lubricants and condensate from the distillation process. From that coolant from the engine jacket we have to the coolant will be circulated, because of from the internal combustion engine that it will be operating from the high temperature. If you maintain the temperature, then only the engine not cheesed. So that condition we have to coolant. From here the very good example from the internal combustion is the radiator for the heat exchanger, shell and tube heat exchanger. Next slide we have discussed about the plate type heat exchanger. From this type of plate type heat exchanger is used for the major cost factor when the temperature difference are not large. One way the meeting this problem in this plate type heat exchanger, which consists of series of separate parallel plates forming the flow passes. Each plate is separated by the next by the gaskets, and hot steam passes in the parallel through alternative plates, while the liquid to be heated passes in the parallel between the hot plates. To improve the heat transfer, plates are correlated. From here we have to using the pasteurization section in the milking packaging plant. From the industrial application we have to using this type of plate type heat exchanger is used for the pasteurization section in the milk packaging plant and the evaporation plant in the food industries. So this type of heat exchanger is used for the food processing industries and also milk packaging plants. You can see this plate type heat exchanger is, if that the product is going from this direction, and after complete of the process it goes to the another direction. So this process is useful for the food processing industries. Next heading is we have discussed about the feed water heater. From that thermal power plant or any other power plant, the feed water heater is very important. If you heat the feed water, we get the efficiency, increase the efficiency of the power plant. From that feed water heater is used for the power plant component, used to preheat the water delivered to steam generating the boiler. So what we have do, it means with the help of the excess flue gases, using the economizer or superheater or whatever from the accessories, to again we have to heat the steam, again we have to heat the excess steam. That steam is again with the help of that feed water goes to the boiler function. So in this process we have to improve the efficiency of the thermal power plant. In a steam power plant usually molded the modified Rankine cycle, the feed water heater is allowed to the feed water to be brought up to the saturation temperature very gradually. This minimizes the inevitable or irreversibility associated with the heat transfer to the working fluid, from here water. From the second law of thermodynamics, the further discussion such as irreversibility. From this graph we have the temperature entropy diagram based upon the Rankine cycle. From FP1 feed pump 1 and feed pump 2. From HPT is denoted for high pressure turbine and LPT is denoted for the low pressure turbine. We have to, from the isentropic expansion process, from the after completion of the turbine, that excess steam is goes to the, with the help of the condenser, it will goes to the feed water heater, after again recirculated to the boiler. So if the processes happen from means we are not allow the excess water from the process of water treatment process. So that condition we have to again and again the recirculating and irreversibility process based upon the second law of the thermodynamics. Next, that is application of the waste heat recovery used for that engine condition. From the already I told about it, from that internal combustion engine, we have to use it for the engine jacket for the coolant. That is a coolant is to the engine is running with above the beyond the limit of the temperature, or it will be from the combustion chamber there will be a high temperature will be passing around from the single cylinder, it will happen 1500 degrees Celsius. But if the multi cylinder means the temperature will be very high. So that condition we have to using for that this type of waste heat recovery system. From here we have to using the, from the exhaust line, what we have to, it means the exhaust gases again we have to recirculate with the help of the hot EGR or cold EGR. It goes to the from the inlet manifold, it will be improve the efficiency, and also we have to control the oxides of nitrogen emission, because of the oxides of nitrogen emission is very poisonous if it comes to the environmental condition. So that condition we have to using for EGR principle. And also we have to rotate the turbine with the help of the turbine to expand the turbine, and coupled with the compressor, again the compressor will be rotating, the high amount of air is entered to the inlet manifold, we get the better combustion. Next slide, we have very important is heat pump is used for generally from the air conditioning system or refrigeration system. That heat pump is the reversible process when while the air conditioner or freezers are familiar examples of heat pumps. The heat pump is more generally used for apply for the many heating, ventilation and air conditioning system. This device is for heating the space heating or space cooling or drying from the room conditions. So and also various application we have to heat pump. Generally the reversible process for the refrigeration system, but it is if you using this heat pump, for example in the automobile, if we have to using for a similar process, if you utilize the air conditioning system from the depending upon the summer climate condition, from the winter conditions there will be some chilling effect. That's why we have to reverse the process done from the refrigeration system. We have to operating the heat pump, we get the chilling, we have to get the hot effect. And also in that air conditioning system it is used for that heat pump is very useful for to heating your room or and increase the temperature of the room. While discussing about the comparing the energy efficiency, the heat pump application is factor for coefficient of performance, seasonal coefficient of performance and seasonal performance factor. This more efficient is heat pump is less energy consuming, it will be more effective, it can be operated. From the applications of the heat pump is already I told about you heating, ventilation and air conditioning system. Whether you can heat the water heating or direct district heating, that is room heating or industrial heating. From that chilling effect or from that flue gases we have to utilize the flue gases or solar heat energy. So various purpose we have to using for the heat pump is a very necessary and also essential use for the heating, ventilation and air conditioning system. From next slide we have discussed about the run around coil. These are also one of the type of heat exchanger. This type of heat exchanger is used for the multi-purpose building because of from the panel board we have to the panel boards are operating from the high temperature. We need is maintaining the temperature from the panel board, we have to using this type of run around coil. Some of the large industrial applications we have to using for ventilation and air conditioning low temperature heat recovery system, because of from that many other industries are available for the chiller plant. So we have to chilling effect creating from the particular shopping mall or very large section from the assembly section, or we have to making the high precision component. So that conditions we have to using this type of run around coil heat exchangers to making the chilling effect or other applications. This is also one of the heat exchangers used for the large applications from that next we have discussed about the thermocompressor. Cases very low pressure steam is reused as water after condensation of lack of any better option. Again we have to reuse. In many cases it became a feasible to compress this low pressure steam by very high pressure steam and also reuse in the medium pressure steam. The majority of the energy in the steam it is in latent heat of value. Thus compressing would have the large improvement for the waste heat recovery system. From this thermocompressor is a simple equipment with also with a nozzle where high pressure steam is accelerated into high velocity fluid. This is entire LP steam, low pressure steam by momentum transfer and then recompresses in the divergent venturi. A figure is represented for the thermocompressor. From that it is typically used for the evaporators where the boiling steam is recompressed and used as a heating steam. Next slide we have discussed about the direct contact heat exchanger. This type of heat exchanger is used from the from here we have to the hot from the venturi, that is from the hot gases enter to the condenser. With the help of that cold water we have to spray that cold water, we have to dilute the steam is supplied by the packing while the cold water is sprayed at the top. The steam is completely condensed in the incoming water, thereby heating. The figure of the direct contact heat exchanger is shown in the that it is the application of deaerator of the steam generation system. Next slide we have discussed about the energy recovery ventilation. So already we have discussed about the energy recovery ventilation, that is a heating, ventilation, air conditioning system. These are all the types of energy recovering from the energy control ventilation systems. Rotary enthalpy wheel, fixed plate, heat pipe, run around coil, thermosipon, tune towers. This is a very effective for the energy recovery ventilation system. And also major advantages of the waste heat recovery systems. These are all the advantages used for that waste heat recovery system. Waste heat recovery system is very essential for the thermal power plant and also gas power plant and various power plant and also cogeneration system. Thank you.